Let's move over to the regression tab. So if you have two variables and they have a reasonably strong correlation, it makes sense to represent the data with a line. And we've done that before. Let's go ahead. So we have our age and speed. So our age and our speed, we want to, let's do speed in miles per hour actually. So we'd like to represent this with a graph, and so we'll insert our scatter plot, two variables, two numeric variables. Now, we want you put the variable on the y-axis that you are predicting. So we are not predicting the age from how fast they throw. We want to know, given their age, what can we predict their speed would be. So I want age on the x and speed on the y. So let's go ahead. You can click on there anywhere. When you click off it, you get this. When you click on it, you should get your chart design, and we want to select our data. And let's edit this. We're just going to call this predicting speed from age. And on the x's, we want h. I'm just going to go from the beginning. So we want the h to Control Shift arrow down to go all the way to the bottom. And then for the y's, we would like the speeds. So I'll click there, Control Shift down, so we've got them all. And so now we have our ages on the x and our predicted speeds on the y. Let's clean this up a little bit. So we have here predicting speed from age. All right, and then down on the x-axis we have age. And then on the y-axis we have pitch speed in miles per hour. So I'll even say we're predicting pitch. We're predicting pitch speed from age. Okay, so what we had done before was inserted a trend line. And then if you click on the trend line, we would play with its formatting. But right now I just want to go down and you can display its equation. So we have its equation. Here it is. And we can use that for prediction. Now let's show you, we can plug in a certain age for x and predict the pitch speed y value. Now let's show you how you can get that using Excel's data analysis feature. So if we go to data analysis, and then regression, we get all out of this. Okay, so our x's are our ages. I'm going to click there, Control Shift down arrow. And our y's are going to be our speed in miles per hour. So I'll click there. And I included the label, the header row, so I'll click label. There's lots of things that we could output, but I don't want to clutter stuff up. That's information for a more complicated statistics class. So we're just going to, where do I want to put this information? I'll put this information right here. I'm not going to check anything else. And here we go. So we get spit out a lot of stuff, and I'll just point out what's going to pertain to this class. So, for example, for regression statistics, multiple R, you can do multiple regression. We're just doing linear regression, but here's our correlation. We see that that's what we had. Now, here are the other relevant information for this class. The coefficients for the line is y equals mx plus b. The x is age, and here's the m. So this would say, let me just say I'm going to merge this. I'm going to merge this. And so we have our regression line. And our regression line is the predicted speed is going to equal m, the coefficient of the x variable, times age plus the y-intercept. So this would be the equation of the regression line. And if we, and if we look here, y equals 1.78x, x is age, plus 40. So that agrees. So what this is if you have an age and you want to predicted speed, the predicted speed is this number times the age plus the coefficient. So we could start here with ages of like 12, 22. Let's just do 12, 14, 16. If you highlight those and then pull down, you can auto fill. I'll do this. And watch what's going to happen. We're going to get an error. Okay, now let's come back up here and look at what's going on. We have the slope of the regression line times the age plus the intercept. But then when we go down, everything moved down as it does. We need this age to move down, but we need these other values to be fixed. And you do that with our dollar signs. We want to keep that value. That one changes, we keep this value. And now, if you pull down, there we go. Now there's still a problem that we're going to talk about. And this is like a little overwhelming. Let's just go down with the decimals here. Okay. So here we have our predictions. And let's look at the line. First of all, you're like, 126 miles an hour? Really? Okay. Well, let's look at the line, and we see if a kid is 12, we're predicting 62. If a kid is 14, we're predicting 65.7. And so you can go through with the predictions, but notice this line is only as good as the data that was used to generate it. The equation of this line came from the actual x and y values of these data points. This line does not extend indefinitely, meaning you can't come down here and say that a 4-year-old is going to pitch 40 miles an hour and a 40-year-old is going to pitch 120 miles an hour. That's called extrapolating. You don't want to go outside of the range. So this range is from like, what is this? X value 11. That's 11. That's 31. So it is, you know, the table that I had, 12 to 32 would be good. I'm just going to say these we're not going to do these. The word is extrapolate. Don't extrapolate. And what extrapolate means is you apply the least square, the regression line outside the region that was of where the data was used to create it. So don't apply the regression line outside of the region of data that was used to create it. You don't know that the linear relationship persists. So our linear relationship will be reasonably good here, but we're not going to use for these higher values. Okay, so this can give you lots of information, and it was a good chance to talk about extrapolation.